Picture the universe as a vast, living orchestra. Countless stars, planets, and moons perform together, each contributing its own note to a cosmic symphony that has been playing for billions of years. Most of this music follows patterns astronomers have slowly learned to recognize. Yet within this harmony, there is one section that has puzzled scientists for centuries, a mysterious movement that refuses to be fully understood. This is where exoplanets enter the story. These are not merely distant planets, they are entire worlds that exist beyond the boundaries of our own solar system, concealed deep within the Milky Way galaxy. Among the unimaginable number of objects scattered across space, there is one exoplanet that stands out with almost unsettling familiarity. It is so remarkably similar to Earth, and yet so deeply mysterious, that many scientists consider it a possible twin of our home world. This story takes us into the captivating domain of Proxima b, a planet located a mere 4.2 light-years away from Earth. In cosmic terms, that distance is practically next door. At the center of this exploration is the James Webb Space Telescope, a technological marvel that is transforming how we search for, observe, and understand these distant and enigmatic worlds. To appreciate the significance of Proxima b, it helps to first grasp the staggering scale of our galaxy. Let your imagination travel across the Milky Way, a vast spiral of stars that contains more than a quadrillion exoplanets. That number is written as 1 followed by 15 zeros. Numbers of this size are difficult to comprehend, so consider this comparison. If each of those exoplanets were represented by a single grain of sand, they would not only fill the entire Grand Canyon, but spill far beyond it. In fact, there would be enough sand to construct an entirely new geological wonder on Earth, something like a Grand Canyon 2.0, stretching for miles and miles. What makes this even more astonishing is that roughly 20% of these planets are classified as Earth-like in terms of their geological makeup and atmospheric characteristics. In other words, there is about a 1 in 5 chance that any randomly selected exoplanet could resemble Earth in fundamental ways. That alone dramatically reshapes how we think about our place in the universe. And the story expands further when we consider moons. Alongside these planets may exist another quadrillion moons, rocky companions comparable to Earth's own moon, each locked into an intricate gravitational dance with its parent planet. If one were to wager on the likelihood of finding another world capable of supporting life, or at least the conditions that make life possible, the universe seems overflowing with opportunities. Now that this immense cosmic canvas has been revealed, it is time to introduce the master tool that allows us to examine its fine details, the James Webb Space Telescope. Think of it as a celestial detective, a kind of Sherlock Holmes of space, except its magnifying glass has been replaced with extraordinarily powerful telescopic instruments. Its capabilities far surpass even the most advanced smartphone cameras imaginable. At the heart of the telescope is its primary mirror, measuring 6.5 meters across, which makes it about 2.7 times larger than the mirror on the Hubble Space Telescope. This enormous mirror allows James Webb to capture incredibly faint signals, detecting the subtle glow of stars billions of light-years away and studying the planets that orbit them. What truly sets the James Webb Space Telescope apart is not just how well it can see, but how deeply it can analyze what it observes. Equipped with advanced infrared sensors and highly precise spectrographs, it goes beyond simple observation. These instruments can separate and study the unique light signatures that celestial objects emit or reflect. From these signatures, scientists can determine a planet's atmospheric composition, its density, its temperature, and even estimate its mass. Acting like a forensic laboratory floating in space, the telescope can search for the presence of water, organic compounds, and even oxygen. With these capabilities, James Webb becomes more than an observer, it becomes an analytical powerhouse. Compared to this, the leap from Hubble to James Webb is not a small upgrade but something closer to a quantum jump. If Hubble once amazed the world, James Webb promises an entirely new level of cosmic revelation. With this expanded perspective, our attention narrows to a single star system that has captured extraordinary interest, Proxima Centauri and its planet, Proxima b. Discovered in 2016, Proxima b immediately distinguished itself as one of the most intriguing exoplanets ever found. Like a complex protagonist in a Shakespearean play, it is full of contradictions and unanswered questions, drawing intense focus from astronomers and astrobiologists alike. So why all the excitement? First, there is its proximity. Proxima b lies just 4.2 light-years from Earth. If it were somehow possible to travel at the speed of light, you could reach it in a little over 4 years. That span of time is comparable to how long a popular television series might take to decline, or how long a single presidential term lasts. In a universe that stretches roughly 93 billion light-years from one end to the other, discovering a planet this close and this promising is like finding a flawless diamond hidden within a mountain the size of Mount Everest. It is rare, precious, and potentially transformative. Proxima B's importance extends beyond distance alone. It may hold vital clues that could reshape our understanding of habitability and the possibility of life beyond Earth. The planet resides within what astronomers call the habitable zone, also known as the Goldilocks zone, of its parent star. This is the region where temperatures are neither too extreme nor too mild, but just right for liquid water to exist on the surface. When scientists imagine Proxima b, they picture flowing rivers, expansive lakes, waterfalls, and perhaps even deep oceans as mysterious as Earth's Mariana Trench. These visions fuel excitement, but they also demand caution. Before we start imagining vacations on Proxima b, it is essential to acknowledge its unusual characteristics. One of the most striking differences is the length of a day. A single rotation of Proxima b lasts about 11 Earth days. That means sunrises would unfold slowly, lingering as daylight gradually emerges, while sunsets would stretch endlessly, creating prolonged periods of golden light. While this may sound beautiful, it would have profound consequences for the planet's climate and overall habitability. Such an environment raises fascinating questions about life. How would human biological rhythms respond to such long cycles of light and darkness? Would people need to eat more frequently during a single Proxima b day? Would sleep patterns remain recognizable, or would they change entirely? Life on this planet could feel both familiar and deeply alien at the same time. Proxima b challenges our assumptions, presenting a puzzle that tests our understanding of what conditions truly make a world livable. So how do scientists gather reliable information about planets that no human has ever visited? This is where the James Webb Space Telescope once again proves its value. It functions like a cosmic Swiss Army knife, combining multiple scientific tools into one platform. Far from being just a telescope, it operates as a fully equipped research laboratory suspended in the vacuum of space. With its sophisticated technology, astronomers do not simply look at distant planets. They examine them in extraordinary detail, using methods that would make even the most advanced crime laboratories seem basic by comparison. Through the use of spectrographs, James Webb analyzes the light that exoplanets emit or reflect. Every chemical element and compound interacts with light in a specific way, absorbing or releasing energy at particular wavelengths. By decoding these patterns, scientists can perform what is essentially a remote biopsy of a planet. This allows them to determine atmospheric pressure, density, and chemical composition, as well as search for substances essential to life, such as water, organic carbon-based molecules, and oxygen. This process transforms astronomy into something akin to space forensics. Researchers are no longer waiting passively for answers. They actively seek them, dissecting the molecular fingerprints of distant worlds. In this sense, the James Webb Space Telescope serves as an eye, a laboratory, an analyst, and a detective all at once. Just when it seems the story has reached its most astonishing point, it takes an unexpected turn. In a twist worthy of science fiction, researchers using the James Webb Space Telescope detected something extraordinary associated with Proxima b. They captured an unusual signal, an electromagnetic emission so complex that it quickly spread through academic circles and across social media, where it was labeled a possible technosignature. The signal was intricate and unlike anything easily explained, raising the tantalizing possibility that it could be evidence of advanced technology. For a brief moment, it felt as though humanity collectively held its breath. Could this be proof that we are not alone in the universe? Yet almost as suddenly as it appeared, the signal vanished. It did not repeat. It left no clear trace behind, only silence and a flood of unanswered questions. Was it merely a temporary cosmic event, a coincidence caused by unusual celestial alignments? Or was it something intentional, perhaps a coded message, or even an echo of a deeper and more haunting cosmic phenomenon? That single emission cast a long shadow of mystery over Proxima b, igniting debates and theories that continue to this day. And still, the story does not end there. New chapters are being written as researchers push the boundaries of exploration even further. Scientists at Harvard are now leading a shift in how we search for extraterrestrial life. Rather than focusing solely on signals and atmospheric clues, they are exploring a bold new idea: using the James Webb Space Telescope as a kind of cosmic night vision device. Their aim is to search for artificial light sources on distant planets, both on their dark sides and their illuminated regions. The implications of this approach are staggering. Imagine detecting the glow of alien cities, shining like luminous pearls against the darkness of space. Picture the faint but unmistakable radiance of vast metropolises, their lights pulsing with the rhythm of an advanced civilization, sending their glow across the cosmic ocean. Such a discovery would redefine humanity's understanding of life and intelligence in the universe. This is where the journey stands today, balanced between discovery and mystery, knowledge and imagination. Let me know what you think about this unfolding cosmic story in the comments. And if you enjoyed this exploration, don't forget to like the video and subscribe.